In the field of data science and machine learning, we use data to extract the information, and for that we use models, and we want to know how much information this model gets from the data. For that we use a measure that is called R squared. So in this video we are going to understand how to calculate R squared and what it is. We have data on mouse size versus mouse weight. So now we want to fit a model on this data to get information from the given data. So the first model is this horizontal line, and this model is called mean weight model. It will give us the average or mean weight of this data to predict the mouse weight. And to know that how much information this model can get from the data, we will find the vertical distances. Vertical distances from the data to line. These vertical distances are called variation. So we can observe here there are greater variation of the data from the line. So by observation we can say that this model, which is called mean weight model, the mean weight model is not the best way to predict the mouse weight. So what we do know here, we will shift the line so that this variation, the vertical distances, can become smaller and smaller. So let's take another line. This blue line looks a good guess about mouse weight. So this line can be a best fit on the data. So let's find the vertical distances, the variation of data from the line. Now you can observe that the variations, that vertical distances, are smaller than as compared to the last one, which is called mean mouse weight model. Now we can compare on this slide that the variation, the vertical distances of mean mouse weight are greater than this blue line. So we can say that this blue line is a line of best fit or best model. So how much this model is best as compared to this mean average model? So we want to calculate a value which tell us so how much this model is good as compared to the last one, or we can say that how much information this model can get from the data. So for that we use R squared. So how to calculate this R squared? So we first understand what are the values we have to plug in this formula. So in this slide you can observe here this is called variation. This is called variations, and what we do here, we take these variation and then we square these variation. Once we take this variation and then we take the square of these variation, then we add all these squared variation. This is called sum of squared variation. Sum of squared variation. That this is the sum of the variation of the model, mean model. And in the similar way we will find the variation of this model as well. This is the variation. These vertical distances are called variation. Then we square these variation and then we add all those square variation. So this is the sum of all the square variation of the blue line is called, let me call it variation of the line, this blue line. So once we have calculated the sum of square variation of the mean model, which is this one, and the sum of the square of this blue line, which is called this one, then we plug in these value in our R square formula, which is over here. you can easily observe the variation of the data from blue line is smaller than the variation of the data from this average line. Now suppose we have calculated the variation of the data from this blue line, these variations, as the sum of the square of these variations we have calculated from the blue line, it is 6, and the sum of the square of the variation from this mean or average line, it is 32. And then we plug in these values in this R square formula and we calculate it. The answer is 81%. What does this 81% shows? It shows that this model, which is blue line here, it gets 81% information from the data, whereas 19% information cannot be explained by this model. That 19% information can be explained something else. Now, how to improve R square value? How to make R square larger? So for that, we can observe that we have to decrease these vertical distances. So in other words, we have to decrease the sum of the square of these variation. So in short, if the data is closer to the blue line, the greater will be the value of R square. And the second thing which we observe, that the mean weight, which is this horizontal line, which is called average line, is not the best way to predict the mouse weight. And one more thing, while comparing R and R square, R is used when direction is involved. For example, to find the negative correlation or positive correlation. Otherwise, R square is the suitable measure. And one more thing, if you compare the values of R, you can see here this 0.7 is not the 2 times of 0.5. But if you take R square of these value, so R square of 0.7 is about 0.5 and R square of 0.5 is 0.25. You can observe here this 0.5 is 2 times of 0.25. So you have to be very careful when comparing R and R square.